Hello everyone, welcome back to the video. So today we are going to see problem number 3197. Find the maximum area to cover all ones. Okay, the second one. So its tag is hard. So let's see, read it and try to understand it. You are given a 2D binary array grid. Okay, you need to find three non-overlapping rectangles having non-zero areas with horizontal and vertical sides such that all the ones in grid lie inside the rectangle. Return the minimum possible sum of the area of these rectangles. Note that the rectangles are allowed to touch. Okay, so we are told we are given a grid with zeros and one, okay, and we need to find non-overlapping first thing, and that area can't be zero, means something or the other will exist, okay. So let's try to see first the example, okay. So here we are given 101, 111. So you can see we can make three rectangles. This is one vertical, the another yellow one vertical, and one blue, that is you can consider vertical or horizontal. So the purple one has area of 2 as it is written, the second blue one has 1, and the yellow one has 2. Okay, so in this way we are getting areas 5, total 5 for these three rectangles. Okay, the next one comes this. Okay, so in this we can make only three rectangles, okay, not more than that. So we have to cover this one. We have to take include that zero also in the yellow one. So this length is 3, that area is 3, this blue is 1, and again purple is also 1. Okay, so it's written, you can see. Okay, so grid dot length is 30, grid ij is either 0 or 1. The input is generated such that there is at least three ones in the grid. Okay, so there will be an answer. So three different ones will be there definitely. Okay. So let's go to the board and try to understand with this example. I'll take my pen. Hmm. So you can see this is one rectangle. Okay. The another one is this, which is in yellow, and another one is okay. So for this, you can see if we try to make like this, it's not allowed. Means if we try to make this one also, so we are including one more zero, and that our answer will increase that. Okay, we will not make that. Also, we cannot make an L-shape section. Okay, and we can calculate that. That is also not allowed. We have to make a rectangle only. Okay, so for this we know the answer. So by observing, we can say that we can either we'll try to make all the three sections. Okay, this is the 1, 2, and 3. Okay, these are the three sections we made. Can we make horizontal three sections? No, because it have only two horizontal lines. Okay, the length is 2, so we cannot make. Let's go to another example here. Okay, so here we can make how many three sections? 1, 2, and 3. So this is one section we made. It will look like this. Okay, 1, 2. Okay, the another one will just shift this box there. Okay, and we can make like this also, 1, 2, and 3. So this one another three sections. We are just making rectangles, not considering if it has one or not. We're just making it. Okay, okay, I'll just erase this one. Okay, also we can make, I'll just show you, we can also consider this one as together and these two as different. Okay, so like this also we can make it. Okay, so how many means for making a three sections out of a rectangle or something, how many lines we need? We'll need two lines, correct? So one line is here and one line is here, so we can see two sections are there, correct? Similarly, if I give one line here and one line here, we make again three sections. That is, one is this, and the other one is this for blue one. Okay. So let's not confuse you. Let's make a another rectangle of 3 by 3. Okay. We are just seeing observations first. Okay. So if I take a yellow one and if I give a straight two lines, okay. So I divide this whole rectangle into two parts. This is the first part, this is the second part, and this is the third part. Okay. Similarly, if I take two horizontal lines, sorry, vertical lines, I will make this as one second and third part. Correct? Similarly, I can do one this line and one like this line. So I will get two parts. This will be one part. I'll just shade it in yellow. Okay, and this will be the second part, and this will be the third part. Okay, so with two lines we can do. So how many two lines combination we have? So let's see in the next page, that one. So you can see these six combinations we can create. Okay, so first one, this horizontal line and one vertical line like this. Okay, then second one same, and the above one we are cutting it like that. Then the third one is two horizontal lines. Okay, so if you see this one closely, these two is just a, reciprocal of the other one. It just, if we are just overlapping it on the other thing, it's the same thing. Like we are taking a line here and we're taking a line on the left and right. It's just like that. And if you also see, if you turn this into 360, it will be same as like this. Okay, so this six lines or cuts only we can make. With that we'll get three rectangles in for that section. So this is clear, right? So what we can do is here, like you can iterate through everything, like from rows and columns, and try to make all possible cuts. Okay, so now we got the three sections, so we'll check for all possible sections. So let's go back to here and see what are our conditions. Okay, so we'll see our conditions also. So our condition is we want all ones covered. Okay, so first we'll make one rectangle. See, we'll directly go with the answer. Okay, so here we are taking one line here. Okay, and one line here. Okay, and if you remember yesterday's question, that is we have to find that the area covering all the ones. Okay, in that we were giving for that particular grid, we were giving the maximum and minimum area, that and the area that cover all the ones. So we will apply that same thing. So we'll take this section. Okay, we'll take first this section and apply that logic to that. Like how much area is required to cover all the ones for this particular rectangle. So this particular rectangle has 0, 1. This is the row. Okay, and from 0 to 4 this is. Okay, so it will have like this: 1, 0, 1, and 0. Now we need to find how much minimum rectangle area is required to cover all the ones in this one. Okay, so whenever for this you will can refer to my previous video. I have detailed explain how to find it. So we'll just iterate through these rows and see, whenever we'll get one, we'll update the max column, max row, minimum row, like that. Okay, so here we'll get answer as 3. Like this section we need. Okay, so it will return 3 to us. Okay, next we will take, now we have taken a vertical line, means these two sections. Okay, this one and this one. So we'll take one by one. Okay, 0 and 1. So here the indexes are 0, not 0, sorry, it will be 1 and 2 here, and the rows will be till 2. Okay, so this is one section we took, and here if we go, we only need 1. Okay, so it will return us 1. Similarly again we are doing same thing, 0 and 1, so it will also return 1. And in this way we are getting an answer of 3 plus 2, 5. Okay, and you can also see here in yellow section there are 3, blue and purple. But we are not only considering that, we are taking the whole sections and doing it. Okay, so I will, I will show you one more example for this. Okay, we'll take a 3 by 3 grid. Okay, here, and we will iterate through Suppose here 1 0 1 1 0 0 1 0, and here also I'll put a 0. Okay, so you can see the answer here. From seeing it, we can say this one will consider, these two will consider, and this one. So this two can be considered as 2. Okay, this one and 1. Okay, but we will just iterate through our solution what we thought, and let's see how it works. Okay, so initially for first part we'll take the horizontal ones. Okay, so this is the section we are going to make. Okay, other than that we cannot make because it has length 3 only. So the first rectangle will return as, okay, first rectangle it will return as 3, because we need to consider everything here so that we can cover all the ones in that rectangle. Okay, this one will give us 1, this one also will give us 1. Okay, so the answer is 5 here in this case. We'll store answer here. Okay, initially it is 5. Okay, so now if I give another one, I'll just write here 0 again. Okay, so the answer is 5 as of now. Okay, yeah, so we'll make another cut here. Okay, the cut will be vertical like this. Okay, so this will give us 2, this will give us 1, and this will give us 1. So the total is 4. We got a better answer, so we'll just remove 5 and because we have to find the minimum area, right? So we got a better answer here. Okay, I'll just erase this part also. Next is, we'll take combination of horizontal and vertical cuts. Okay, so if I give a horizontal vertical cut here, then I can give a horizontal cut here. So it will give me this one section, this whole one section, and this one section. Okay, so for this it will return me 2, this it will return me 1, and for this it will return me only 1. Okay, so like this also we can get an answer. So it's 4, we will not update anything. Okay, so next cut will make a horizontal here. Okay, and a vertical here. So we need to consider all these things. So it will return me as 1 2 3 4 5 6, and this will return me 1. So it is 7 more than, so we no need to update it. Okay, so in this horizontal cut only, there is another cut, this one, but as it of no use, we'll go with other cut. Okay, so we can do another thing, like first vertical cut, then two horizontal cut. So first we'll consider this one. Okay, so this will give us 2, this will give us 1, and this will give us 1. So it will again compile to 4. Okay, we'll not do any changes. Okay, so now this time we have made a cut here. Now this time we'll make a cut here. Here the horizontal cut will be here, keeping the same vertical cut. Okay, so we'll get this area, this will return us 4, this will return us, this combined will return us 2, and this will return us 2. So it will be more, so we'll not consider that because we want to find the minimum. So as of now minimum is 4 only. Okay, so as we started the cuts from left, same way we'll start from right also, and we started from top, same way we'll start from bottom also, and in that way we can include every section, and for that we'll calculate the minimum area required to cover all the ones. Okay, so hope you get this. Let's go to the problem. Okay, I've written the solution, so I'll explain it line by line so that we can get it. First we'll see like how we'll finding the minimum area. Okay, I'll just zoom in a little bit. Just give me 1 minute. Okay, okay, so this is the main minimum area. Okay, so this one is the previous problem solution. If you can go there and see, you will get it. So we are just iterating through the grid. So here I have given row start, row end, column start, column end. So that rectangular portion I have given actually. So I have passing the rectangular start end points, like row start is 0, row end is 1. column start is 0 and column end is 4. So whatever it is, I'm passing it. And for this section only, our function will iterate and find the area required, the minimum area required to cover all ones in this section. Okay. So suppose this is the thing. This here it is 1, here it is 0, and here it is 1, and here it is 0. So it will return us 3. Okay. Because we need only these 3 blocks to cover all the ones. Okay. We don't need this fourth block. Okay, so it will just iterating, and if you see here, it is just minimum. I'm updating with I as minimum, max h with maximum of I. So it will give me the row height and width. Okay, and you can see I have written here, just erase this part. Okay, I've also written here something, if max h equal to -1, return. So we cannot take a 0 value because it is clearly mentioned non-zero. Okay, so for that we are returning integer on max value. So this function is for calculating for one rectangle that we are passing. Okay, and there is another function, this one public int sum. I'll just erase this part. Okay, so this one does like it will take all the three section values, that is A, B, C, and check if it's integer or max value or not. And if it is there, it will return integer max. Otherwise, it will return a sum of A, B, C. Okay, it's simple. So let's go to the main function now. That is minimum sum. What we are solving now. Okay. Initially, I've taken two variables, total row and total column. Okay, and one answer I've initialized with the multiplication, that in the worst case the maximum thing we can get is the whole grid. Okay, so that I have done here. So initially we'll take horizontal. Okay, for this one, suppose this is the grid. Okay, so I'm taking in this loop, we are just checking the horizontal sections, that is like this, cutting it like this. Okay, we'll check all the possible horizontal sections. Okay, for this, so if you notice the code, we are just iterating from row. This loop is also running from 0 to 2, suppose, and the internal loop, that is j loop, is also running from 0 to 2. We are not running for column here. Okay, we are running for j only. So it will start like from this 0 to I. Suppose 0 to I means this will be the first section. Okay, so this will be the first section in this case. Then the second section will be I plus 1 to j. Okay, I plus 1. So I plus 1, this will be 1 because I is 0, and 2 j. So I'll just write down one iteration for you guys. So A will be starting index will be 0, I will be 0, and these all index are inclusive. Okay, yeah, and what will be the column? We'll consider the whole column from 0 to column minus 1. Okay, column minus 1. Yeah. So B value. So B will start from the next thing. Okay, this is 0, 0. So it is I plus 1, like 0 plus 1, 1. And what will be the J value? It will take that, and this will be same. Like columns we're considering from 0 to whole. Like this whole column will consider. That's why we are writing 0 to C minus 1. Then the next third section will be J plus 1 to total rows. How many rows we have, right? So row minus 1, because it is inclusive, like the function we have written, it is inclusive. Okay, to 0 to c minus 1, c minus 1. So hope you get it. So whenever we'll iterating, we'll first take a cut here, then see all the possible cuts down. Okay, if we had one more thing. Okay, so first the second cut we'll make here, the second cut we'll make here also. So like that we'll do. Okay, I'll just erase and make it. Okay, so suppose we have this four things, one, two, three, four, four sections. Yeah, so we're just making horizontal cuts first. So I'll show you how we'll make. So suppose we took this first cut, then how many options we are having to make two cuts? This line, like zeroth line, we already made it, one and two. So we'll try for one and two both. Then we come back, our I becomes one. Okay, now our first cut is here. We don't have any options. We have to make only one cut now at two. Okay, So we'll go with that only. Then our I becomes 2 directly, 2. We don't have any options and we don't continue this loop and we'll stop here only. Okay, that's why we are running from total row minus 1, you can see. So we'll never reach to 2 because we are running till 0 to 1 only. Okay, so in this way we'll do for horizontal. The same way I will show you for vertical also. Okay, so this is for vertical. So let's make a thing again. Okay, 1 2 3 4. Okay, so whenever initially the I will be there, so we'll take a cut here first. Okay, okay, this is done. So now 0 1 2 3 4. Okay, so we have how many options left? We have two lines, means two options left. So we'll try with two ones and we'll try with three ones. Okay, then we'll go, our I will become 2, we'll take here, so this will become one section, the whole one section, and we have only one option left, that is 3. We'll try with that and then this loop will stop. And also with that we are calculating the answer, we are adding it to the minimum, like mat.min answer and d is what, submission of ABC. You can see that method we have written for that only. So first we are calling all the three sections and taking its sum and checking if it's minimum that answer and adding to answer. So this is done. This was the easy part. Let's see more complicated part, that is one vertical, one horizontal. So for that we'll iterate from other loop, and here you can see we are iterating from I to row and j to total columns. So we're not iterating for the same thing here. Okay. So first top horizontal, then vertical. So let's make another thing here. 1 2 3 1 2 3. Okay, so I'll take a different pen to just make a cut. Okay, so first top horizontal, so first we'll make this cut. Okay, after making this cut we got this section. Okay, so for this section I will just mark it in green. Okay, we have to make one cut for vertical things, so we can make one cut here. Okay, one cut here, one cut here. So all these three cuts are possible. Okay, so for all these sections we will calculate the minimum area and just add into the answer if it is minimum than that. So similarly we are doing it for horizontal also. So this is first horizontal, like top we did a horizontal cut. Okay, sorry, I have to make again and again. So when we make a horizontal cut at top, okay, so similarly we make a bottom first and then cut the upper section for the vertical cuts. Okay, so this is just vice versa. See, you, if you can read this one, first top horizontal, then vertical, first bottom horizontal, then vertical. So first bottom cut we'll take horizontal and the above section will cut vertically, like that. And in the first one we are taking the above section cut as horizontal and the below section we are taking vertical cuts, like that. So similarly here we are doing, first we are taking a vertical cut, so this section one rectangle is done, so whatever the remaining section will cut horizontally, this one, like that, and the vice versa of that. So this is done and we'll just return the answer. Okay, so we'll try to run the code and see if it's working. Yeah, it's working. Let's try to submit it. Yeah, it's working fine. So here the time complexity will be m cube n cube, m cube n cube, and space complexity will be big of 1. I'll show you. See, this is all already n square, okay, or m into n, that will be m square or something. And again we are calculating this minimum area, and for this minimum area also we are iterating through the grid. So it will be m cube n cube, like that. So hope you understand this. So we have seen this part. Okay, So this vertical and straight horizontal cuts are easy. So I'll show you iteration, one iteration for this example for this horizontal and vertical cut and vertical cut first. Okay. So we'll make a grid same like that. Or what we can do is we can just consider that same thing. Okay. And we'll take the cuts. Okay. So what is written first? Top cut. Okay. So we'll go one by one, line by line. We'll see, we are seeing this line first. Okay. So we are considering 0 and I. Initially here I equal to 0 only. Okay. I is 0. So it will take a cut from 0 to 0 inclusive and total row 0 to total row columns. So it will consider this one first. Okay. This cut it considered. Now it remaining with this section, the below section. And for that it will take the first cut here. Okay. And the second cut here. I will show you how. I plus 1, that is 1 because I is 0, correct? And total row minus 1 means it will be 1 to 2 like this. So this will be constant because row we have that much only. We have left with this section only. So it will change this column section 0 to j plus 1. So 0 to what is j? J is 0 and j plus 1 and j plus 1 to total column minus 1. So total column means ending till ending 0, 1, 2, 3, 3 it is. So till ending. So these are the three sections. So I will take a different pen and I will write the sections. This is the one section. This is the second section. Okay, correct. And this whole is the third section as of now. I'll just mark it in yellow. Okay. Yeah. And after the j is iterated again, okay, when the I section will be fixed. Okay, now we are iterating for the j. So now here it will give a cut. Okay, this is a cut now. And our sections will be this one and this one. Okay. So in this way, it will calculate it and will update the answer. So now one example I will show you for the vertical cut first and then horizontal cuts. So we'll take this one. Okay. So now we'll see the first left vertical and then horizontal cuts. So if you see this one is vertical and these two are horizontal cut, the code for horizontal cuts. Okay. So we'll see this first. So I equal to 0 here initially. So 0 to total row minus 1 and 0 to j. So j will be also 0. Okay. J is also 0 here first. Okay. So let's take this first cut, that is 0 and total row minus 1, this whole section, and how much is the width? 0 to j. So it will give a cut here, will give a cut here. And we are remaining with the remaining right side section. So now we need to give a horizontal cut there. Okay. So the only possible way to give a horizontal cut now is this part. Okay. We don't have more length to give horizontal cut. Still we'll see what is the iteration 0 and I. Okay. 0 and I, j plus 1 to total column minus 1. So see, this is j plus 1 and we are considering total column minus 1. Means this section we are considering and 0 to I. Okay, means 0 to I. So this is the first section, I plus 1 to total row. This is the second section. We are giving I plus 1 to total row minus 1. And this will be constant, j plus 1 to total. So next we'll just change I and j. I and j will become I will be 1, j will be again 0. Sorry, j will be again starting with I guess. Yeah, it will be 0 again. Okay, erase this part. We'll remove this cut. And the next one we'll give here the cut. Okay, and we have one this section and other cut. So this is the other section, this is the other section. So in this way, first vertical and then horizontal cuts. Like that, we are solving this problem. So hope you get the problem and you like the explanation. I tried my best. So it is a hard problem. Please practice it. If you write it by yourself, so it will be better. I will provide the code link in the description. Please go through it. And if you have any doubt, please comment down. I will try to help you guys. Okay, thank you.